In medias res, building tension. The year is 1566. In the dark streets of Rostock, Germany, two silhouettes circle each other with drawn swords. This man lost part of his nose over an argument about mathematics. And somehow, that wasn't even the strangest thing he did. That man was Tycho Brahe. He was a 16th century Danish nobleman with a massive fortune and a notoriously quick temper. The duel started over a drunken dispute with his cousin, Manderup Parsberg. They disagreed over a mathematical formula, and they decided to settle it in the dark with broadswords. In the chaos of the fight, Brahe lost the bridge of his nose. Rather than live with the visible disfigurement, he had a prosthetic nose crafted to mask the injury, which he wore for the rest of his life. This creates a strange contradiction. The same chaotic, noseless brawler who fought relatives in the streets over math would eventually become the last great naked-eye astronomer in history, compiling the exact data that laid the groundwork for modern physics. The historical legend surrounding Brahe's wealth and eccentricity often claims that his replacement nose was cast from solid gold and silver. The truth is a little more practical. When researchers exhumed his skull in 2010 to run a chemical analysis, they found high traces of copper and zinc. His everyday prosthetic was actually made of brass. To keep it attached, Brahe carried a small box of paste in his pocket. Whenever the heavy brass nose came loose during the day, he would casually pull out the putty, apply it, and glue the piece right back onto his face. Strip away the polished myths of solid gold, and you find a man whose daily routine involved gluing a piece of brass to his face while charting the heavens. His obsession with the stars began after he witnessed a solar eclipse in 1560. He checked the existing planetary tables and realized the accepted astronomical calendars were wildly inaccurate. King Frederick II of Denmark eventually stepped in, granting Brahe the island of Ven and the funds to construct Uraniborg. Building an observatory before the invention of the telescope required immense architectural precision. The complex floor plan and cross-section show how the entire building was essentially designed as one giant, static scientific instrument. Brahe relied on metal tools, like this armillary sphere, built with heavy rings to track celestial coordinates. Bolted firmly into place, they didn't shake in the wind, allowing him to achieve a precision of 1 arcminute, a 60th of a degree, using only his eyes. He was running the 16th century equivalent of a Silicon Valley tech campus, leveraging immense wealth to obsessively chase a perfect dataset. But the rigorous mathematical order of his stargazing stopped at the observatory doors. Inside the castle, he maintained an underground alchemy lab and ran a deeply chaotic household. His regular dinner parties featured a clairvoyant dwarf jester named Jep, who would sit under the banquet table and offer predictions to the guests. And roaming freely through the castle halls was the ultimate symbol of his bizarre wealth, a tame pet elk. The elk's residency ended during a lavish banquet. After drinking copious amounts of beer, the animal stumbled down a steep stone staircase and died. Between the wild parties, the subterranean alchemy, and the drunken livestock, the atmosphere resembled a Renaissance frat house. Yet, this exact environment produced the most reliable scientific data of the era. The party ended when Brahe lost his royal funding after a dispute with the new Danish king. He relocated to Prague, where he hired a brilliant, struggling young mathematician named Johannes Kepler. Their partnership was brief. In 1601, following a royal banquet in Prague, Brahe fell severely ill and died in agony days later. His final resting place reflects his high standing, buried with honors in the Church of Our Lady before Teen. His sudden death immediately fueled rumors. Some suspected his bladder ruptured, others whispered Kepler poisoned him to steal his lifelong data. A 2010 exhumation settled the murder theories. Tests on his hair and bones ruled out mercury poisoning. The physical evidence pointed to benign prostatic hyperplasia, an enlarged prostate that shut down his kidneys. A mundane biological failure ended the life of the great astronomer, but his death meant his life's work safely transferred to the exact person who needed it. Brahe was gone, but he left behind a priceless legacy. For 38 years, he had recorded the most accurate, continuous astronomical observations ever made without a telescope. Johannes Kepler inherited that massive dataset. He immediately set to work trying to map the orbit of Mars, relying on the ancient assumption that planets moved in perfect circles. This diagram shows the expected circular orbit. But when Kepler plotted Brahe's hard observational data, he found an anomaly. The scatterplot data points deviated from the perfect circle by a microscopic margin of just 8 arc-minutes. For any other astronomer, an 8-minute discrepancy would be written off as an observation error. But Kepler knew Brahe's methods were flawless. He trusted the data over the accepted theory. That tiny gap forced Kepler to abandon the idea of perfect circles entirely. It led him to discover that planets move in ellipses, forming the laws of planetary motion that still govern astrophysics today. Tycho Brahe could predict the position of planets with astonishing precision, but apparently not what would happen if you gave an elk too much beer.